Now let's look at examples using elimination. The first thing you're going to do when we're doing elimination is to multiply the first and or the second equation so that one of the variables has opposite coefficients in both equations. Then we're going to add the equations together and solve for the remaining variable and plug anything that we get from that back into one of the other two equations so that we can figure out our final variable. In this example, we have negative 2x plus y equals 8 and 3x plus 2y equals 9. So you can pick either of your two variables to eliminate first. In this situation, I'm going to eliminate y because I only have to multiply one of the equations by a number so that they'll have opposite coefficients. So with that, I'm going to take the first equation, and since I'm eliminating y, the second equation has a positive 2. That means I want the top equation to have a negative 2. So to get that, I'm going to multiply every single piece by negative 2. So now, if we multiply everything by negative 2, our first equation becomes 4x minus 2y equals negative 16. And now that we have opposite coefficients for one of our variables, we can add the two equations together. That's going to eliminate, hence the name elimination, that'll eliminate our y variable. So we're left with 3x plus 4x, which is 7x, equals 9 plus negative 16, which is negative 7. And we can solve for x. So then x here is negative 1. Then we have this value of x. We can plug it back into any of these three equations, it doesn't matter which one, to figure out y. I'm going to use the top one. So we have negative 2 times negative 1 plus y equals 8. 2 plus y equals 8. Subtracting 2, we get y is equal to 6. So the solution of these two equations is the point negative 1, 6. Notice this was the exact same equation that we did for our substitution problem at the very beginning. Let's do another elimination problem. Negative 5x plus 2y equals 32, and 2x plus 3y equals 10. Looking at this, there isn't something that I could just multiply one equation by to get opposite coefficients for my variables, so I'm going to have to multiply both equations. I'm going to choose x, because one of them is negative and one of them is positive. So when I do that, I'm going to multiply the top equation by the coefficient of x on the bottom one, multiply the bottom equation by the coefficient of x on the top one. So what that looks like, I want my x's to have opposite coefficients, so I'm going to multiply the top one by 2 and the bottom one by 5, because when I do that, once I multiply the top by 2, I have negative 10x plus 4y equals 64, and on the bottom I have positive 10x plus 15y equals 50. So I had a negative 10 and a positive 10, which is exactly what I wanted. Now I can add my two equations together and eliminate that x so that I only have y, and it's a lot easier to solve. So 4 plus 15y is 19y, equal to 114, and 114 divided by 19 is 6, so the y value is 6. Now I can use any of these four equations. It doesn't matter which one. I can use the original ones, or I can use either of my new ones. And I'm going to substitute y into one of those equations to figure out x. I'm going to use the second one, because the numbers are smaller. So we have 2x plus 3 times 6 equal to 10, which is 2x plus 18 equal to 10. Subtract the 18, 2x is equal to negative 8, so then x is negative 4, which means the place that these two lines are going to intersect on a graph is at the point negative 4, 6.